Children, today we are going to learn about ionization of weak acids. Already I have taught that weak acids are partially dissociated in water and there is an equilibrium existed between the undissociated acid and its dissociated ions. For example, consider a weak monobasic acid HA. When dissolved in water, it forms H3O plus reversible reaction, hydronium ion plus A minus. Then applying law of mass action, otherwise law of chemical equilibrium, it is given as constant Kc is equal to H3O plus concentration into A minus concentration by HA concentration and water concentration. Square brackets are represented as concentration. In dilute solutions, because it is a weak acid, so in dilute solution, water concentration will be in excess. So that water concentration can be kept as constant. So Kc is equal to H3O plus concentration, A minus concentration by HA concentration, water kept as constant as K. This Kc and K into K, multiply the product of the two constants Kc and K gives another constant called Ka. Ka means dissociation constant of weak acid. This also varies with temperature. So Ka gives this H3O plus can also be written as H plus, because H3O plus indicates that hydrogen ion is hydrated. That's all. So for simplicity, it may be replaced as H plus, A minus concentration by HA concentration, Ka. This is for weak acid. Similarly, for weak base, how will you write? Kb equals to B plus concentration, OH minus concentration by BOH concentration. So next, based upon this, we are going to learn one law called Ostwald's dilution law. Ostwald's dilution law relates the dissociation constant of the weak acid with its degree of dissociation alpha and the concentration C. Ka means dissociation constant of the weak acid with its degree of dissociation alpha and its concentration C. What is meant by alpha? Alpha is equal to number of moles dissociated by total number of moles. This formula I have to learn. Alpha, number of moles dissociated to total number of moles. So now based upon the Ostwald's dilution law, we are going to derive Ka for a weak acid. Now consider acetic acid. It is one of the weak acid, giving CH3COO minus plus H plus. Already I told weak acid partially dissociated. So there exists an equilibrium between the dissociated ions and the undissociated acid. Always a weak acid means there exists an equilibrium between the dissociated ions and the undissociated acid. So now dissociation constant for this acid is equal to CH3COO minus concentration, H plus concentration by CH3COOH concentration. Now for calculating Ka, we are drawing a tabular column. Here acetic acid, acetate ion, H plus ion. First initial number of moles consider as 1 starting of the reaction. There won't be products. Next, degree of dissociation alpha. Get alpha also, giving alpha, alpha. Now what is the remaining number of moles? 1 minus alpha, alpha, alpha. Then moles at equilibrium concentration. At equilibrium concentration, 1 minus alpha into C, alpha C, alpha C. Substitute these values in Ka. So what is Ka? Ka is equal to H plus concentration, value is alpha C, into CH3CO minus concentration, value is alpha C, by 1 minus alpha into C. C get cancelled. Therefore, alpha square C by 1 minus alpha Ka. Here, compared to 1, that alpha is so small. When compared to 1, alpha value is so small. So, hence the denominator, we can write Ka is equal to alpha square C by 1. That is, Ka is equal to alpha square into C. So, from this, what is alpha square? Ka by C. From this, what is alpha? Ka by C, the square root. Alpha means degree of dissociation. Now we got degree of dissociation. Alpha is equal to square root of Ka by C. Now let us consider an acid with Ka value of 4 into 10 power minus 4. And we have to, this is Ka value for an acid. Now the degree of dissociation of that acid for two different concentration. One concentration 1 into 10 power minus 2 m. Other concentration 1 into 10 power minus 4 m. So using the above expression, first we can calculate for this one. 1 into 10 power minus 2 m. Concentration. So alpha we have to substitute here. Square root of Ka value 4 into 10 power minus 4 by 1 into 10 power minus 2 getting cancelled. 4 into 10 power minus 2 alpha. So alpha is equal to 2 into 10 power minus 1, that is 0.2. Now with this concentration, alpha is equal to square root of 4 into 10 power minus 4 by 1 into 10 power minus 4. This get cancelled. Is equal to square root of 4. So alpha is equal to 2. So from this, what do you understand? When the dilution increases by 100 times, concentration decreases from 1 into 10 power minus 2 m to 1 into 10 power minus 4 m. That is, the dissociation increases by 10 times. When dilution increases by 100 times, dissociation gets increased by 10 times when compared the both. 0.2 to 10 times difference when comparing the both. Thus we conclude that when dilution increases, degree of dissociation of weak electrode get increases. This statement is called as Ostwald's dilution law. This statement, that is, when dilution increases, degree of dissociation of weak acid also increases. This statement is known as degree of dissociation. Now, the concentration of H plus concentration of H plus can be calculated as follows. H plus concentration is equal to alpha into C. Alpha into C. Alpha means degree of dissociation, C is molar concentration. Alpha value already you know, square root of Ka into C. So substitute here. Therefore H plus concentration is equal to square root of Ka by C into C. So now to bring this C inside, we are using Ka into C square by C. This get cancelled. Therefore H plus concentration is equal to square root of Ka into C. Similarly, for a weak base, OH minus is equal to alpha into C, or OH minus is equal to square root of Kb into C. Kb into C. Children, up to here you have to write for us. This is very important question, but easy to follow. Alpha value, then dissociation, then tabular column you have to write. Then find for Ka. From Ka find for alpha. Then Ka value given, 2 concentrations, one value 0.2, one value 2 we got. So we conclude that the dilution increases, concentration increases 10 times. 10 times from this. Then H plus value we got. Similarly OH minus value we got. Everything you mark in the book. It is given in book page number 13 and 14.